previous class discussion, we covered quite a lot in terms of sets. Now today, in this short video, I want to introduce set difference and symmetric difference. But I thought it is very, very important for us to at least make a review of what we mean by union of sets and then the intersection of sets before we go into look at set difference and symmetric difference. And I want to make it clear from the onset that we need a clear understanding of these operations on sets before we can move on to make proofs to prove equality of sets, for example, and all the various proofs that come along. Yes, I'm going to make a second video on proving sets. But before that video, I thought perhaps it is very, very important to make a short video where we are just going to focus on union of sets, intersection of sets. But our main focus basically is on the difference between sets. What do we mean by the symmetric difference? Now, let me start by the union of sets. When we are talking of set A union B, we are simply referring to a new set that is formed when we combine all elements that are in A and also all elements that are in B, and making sure that those elements that are repeated are only written once. I'm going to illustrate this by a simple example. Suppose A is the set 1, 2, 3, 4, 5. And the set B is the set 2, 4, 6, 8. Now set A union B, basically we said we are combining all elements that are in A. We put also all elements that are in B to form the union. I want you to understand the union of sets in the usual state. When we say this company has been united with this company, all the employees that are in that company and all the employees that are in this other company, they will come together. We find in the union now, we find all the employees in that company working together with the employees from the other company. But if there was a particular employee who used to work for company A and B, there are some employees who work for two companies. For example, we can find a lecturer teaching in two universities. When those two universities combine, in this case, for example, this is a lecturer in University 1, but that is the same lecturer here. We won't find this lecturer now becoming two, because this is basically the same person that we are referring to. So now in the union, we will say one. I want you to take note, 2 must be written once in the union. Then 3, 4 must be written once in the union. 5, 6, 8. This is the union between two sets. Now, what is the intersection? The intersection is straightforward. Basically, common elements. The new set that is made up of common elements between the two individual sets. So, A intersection B, and I want you to take note of the sign. Union intersection will be the set that is 2 and 4. So this is the intersection between A and B. In other words, when we are saying what is A intersection B, we are saying which elements are common in A and also in B. Which elements are found both in A and in B. That is basically what we mean by A union B and A intersection B. Now we want to move a step further to look at the set difference. Set difference is written A difference B. What is this? Set difference simply refers to elements that are found in A but not in B. Elements which are found in A but not in B. We can also write this as A minus B. All elements that are in A, but remove those that are in B. Now, set difference A, B would be equal to, now we are using the same example. what are the elements which are in A but not in B? So in other words, 1 is in A, but it is not in B, so we retain it. But when we go to 2, because 2 is in B, we don't write 2, even though that 2 was in A. So it will be 1, 3, sorry. 3 must come, because it is not in B. But 4, we cannot write 4, because even though it's in A, because we're saying all elements in A, but not in B. So 1, 3, and 5. That is A set difference B. I want you to understand the definition very well, because when you are required to prove, and in what you are required to prove there is set difference, you must have a clear definition of what we mean when we are saying A difference B. So all elements that are in A, but those elements are not supposed to be in B. In our case, we have A being equal to that, B being equal to that. So when we go to A set difference B, we make sure that everything that is in A, we put it. But whatever we are putting, we must remove what is in B. Now, what is B difference A? This is the same as B minus A. So in this case now we are looking at all elements in B excluding those that are in A. So we cannot put 2 because it is here. We cannot put 4 because it is here. But we can put 6 and we can put 8. This is basically an illustration of A difference B and B difference A. And I want you to analyze properly how we are getting this. Elements in A but not in B, elements in B but not in A. Now let us move to the final part where we need to look at the symmetric difference. Symmetric difference. How do we write the symmetric difference? Symmetric difference is between A and B is A, we put a small triangle. This small triangle simply means A symmetric difference B. Or sometimes we write A and we put this one across, it simply means symmetric difference B. What is this A symmetric B? See, I have decided to put the symmetric difference together with the ordinary set difference so that you can see clearly how the two differ. Now, A symmetric B is the same as elements in A, we remove those that are in B, union elements in B, and we remove those that are in A. Now, what are we saying here? You can see that A minus B is the same. We can write it like this. So we can still write this as A difference B union B difference A. So what it simply means is this can also be written as A union B difference the intersection between A and B. I'm going to use a separate example here to illustrate this so that you have a clear picture. But before I use that example, let me show you the region A set difference B in the context of a simple Venn diagram. Suppose we have our universal set this. So when we talk of set difference A and B, we have A and B. The elements that we are referring to are these ones. Elements in A and also elements in B, but we must exclude the intersection. So this shaded region is A difference B, union B difference A, which is the same as A set difference B. Now, maybe I need to use an illustrative example here so that we have a clear picture of what we are talking about. Let me say we have our universal set U, let me say it contains X such that this X is between 0 and up to 12. And let me define set A as the set containing X such that X is an element of even numbers. And let me have B containing X such that X is an element of prime numbers. I want to illustrate the set difference A, set difference B. Now, and I want you to take note that A cannot have elements that are outside the universal, and B cannot have elements that are outside the universal. So A is the set containing X such that that X is an even number, but that even number must also be taken from the universal. And B contains X such that X is an element of prime numbers, and it must be within the universal from 0 through to 12. So we can simply write our A, and I want you to appreciate from our introductory course where we said we have used set builder notation. So you must also be able to list. You must be able to list the elements when you are given a set which is defined using the set builder notation. So we'll have our A as even numbers between 0 up to 12. It's 2, 4, 6, 8, 10, 12. Prime numbers between 0 up to 12. We start with the 2. Remember, 2 is the only prime even number. 2 is the only even number which is also prime. So 2, 3, 5, 7, and 11. A prime number has two factors, 1 and itself. And that definition is assumed, and you must know. Now, what is A symmetric different B? A symmetric different B. All elements that are found in A and also in B, but not in the intersection. Do we have anything in the intersection? Yes. What is that? 2 is common. 2 is found in A and it's also found in B. So it is in the intersection. But the set difference must be all the other elements excluding those that are in the intersection. So the only element that is in the intersection is 2. You see 2 is in A and is also in B. So you must exclude it so that we list all these. So we have 3, we have 4, I'm just writing them, 5, 6, 7, 8, 10, 11, and finally 12. So these are our elements. That is A symmetric difference B. Remember the way I gave you, A symmetric difference B is the same as A difference B union B difference A. What is A difference B? Just to verify, but of course we are going to get that. A difference B, all elements in A but not in B. All elements in A but not in B. What are the elements in A which are not in B? So we have 4, 6, 8, 10, and 12. Okay? What is B difference A? All elements in B but not in A. B not in A. 3, 5, 7, 11. So if we unite this, what is the union? Union all elements in this set and also in this set, but we must make sure we don't double count. So A difference B union B difference A, which we said is the symmetric difference, will be the set 3, 4, 5, 6, 7, 8, 10, 11, and finally 12. And if you check properly A difference B union B difference A, that is exactly what we got as A symmetric difference B. Now, if you are to go and produce a Venn diagram using the information given, you would realize that A symmetric difference B will be the shaded region. So let me just, in conclusion, show off this one. Show to you it's our universal. So you see, when we are completing this Venn diagram, we start with what is on the intersection, which is 2. So, but A has got 2, 4, 6, 8, 10, 12. So we put the other elements 4, 6, 8, 10, 12. Then this is our A. For our B, we have 2 already in the intersection. We don't put again outside here. So we have 3, 5, 7, 11. Which other element is 0 is outside A and B, so it must come here. Okay? So if you check properly our A symmetric difference, now you can see that A set difference B is actually these elements here and these elements here, and 2 is not included. So this is exactly what we have. So set difference is the union between the differences of the two sets. That is A set difference B is actually A difference B union B difference A. And that is the region. Thank you very much. We have managed in this video to review the union and the intersection, but our main interest was to show what do we mean when we talk of set difference and what do we mean when we talk of symmetric difference. In the next video that will come, we are going to look at proving sets using mathematical reasoning, or simply what we call logical reasoning. Thank you very much. Meet in the next video.